In this video, I'm hoping to connect this old Texas Instruments portable terminal up to my Mac. Why? Because I think it would be fun to try. But first, what is a terminal? A terminal is a device that allows data to be entered and displayed. Early terminals had an input device, such as a keyboard, and an output device, such as a printer or video display, that is, a monitor. The very earliest terminals had printers because they were reliable and relatively inexpensive compared with video displays, and also, of course, because they provided a hard copy. The first terminals had no processing power at all. They sent and received data one character at a time. There was no memory beyond a single line of characters, so a few hundred bytes of memory at most. Formatting of the printed page or screen, if any was done at all, was managed by the remote computer. This style of terminal was later dubbed a dumb terminal, to contrast it with later terminals called smart terminals that had their own CPU and memory, and had features like screen formatting and editing. In this video, I'm not going to get deep into the details of serial communication or into the particular features or architecture of this terminal. Let's take a quick look at this TI Model 707. First, I must acknowledge Steve from Brampton, Ontario, who reached out to me and generously offered me this terminal. Thanks again, Steve. The TI Silent 700 was introduced in 1971, but this is a later version called the Model 707 and came out in the early 1980s. This one is much smaller and lighter than the original and is a featherweight at only 2 kilograms or 4.5 pounds, and only 8 pounds including batteries. It has a very comfortable mechanical keyboard for data entry and can produce all 128 characters. That is, upper and lowercase letters, numbers, symbols, and non-printing characters such as space, line feed, return, and so on. There are no arrow keys, but there are some special function buttons like command, line feed, paper advance, control, and escape. I think it's funny that the return key is no larger than any other character. There are also 3 indicator LEDs and 3 rocker switches. For data display, it has a thermal printer, which can print 80 or 132 characters on each line. It can respond to certain commands called escape sequences, but overall this would qualify as a dumb terminal. In terms of speed, the printer will print up to 46 characters per second, or 2 to 3 seconds to print a line. To communicate with other computers, it has an interface that sends and receives 1 character at a time at a rate of 300 baud, or 30 to 40 characters per second. The Model 707 has 2 options for connecting to other computers, and both involve using the telephone line. The first is a direct connect modem, which converts the data bits to audio tones and sends them over a wired telephone line via a cable. The second, which is very primitive indeed, is a connector to an acoustic coupler accessory. With an acoustic coupler, you place a landline's telephone handset onto the coupler, and the modem tones are picked up by the handset. I need to make the terminal think that it's connected to a phone line. To do this, I'm going to use a vintage external modem. This is a Hayes Smartmodem from about 1982. Believe it or not, it cost $700 in 1982. The Smartmodem 1200 actually supports data rates up to 1200 baud, but can negotiate speeds down to 300 baud or less. 300 is what we need. I will use a standard landline telephone cable, RJ11 male to RJ11 male, to connect the Model 707 to the phone side of the Hayes Smartmodem. Now we're going to have to start thinking about the Mac and how we're going to get it to connect to the Hayes Smartmodem, both in terms of hardware and software. On the data side of the Smartmodem is a 25-pin female D connector. We'll just call it DB25 female. It's labeled RS-232C, which stands for Recommended Standard 232 version C. We'll just call it RS-232C. It was a ubiquitous standard that defined the interfaces for connecting 2 serial devices together. What was often a modem, called Data Communications Equipment, or DCE, to another device, called Data Terminal Equipment, or DTE, in this case, my Mac. Next, I need a converter that translates RS-232 to something modern like USB. So-called serial to USB adapters are available for under $10, so I picked one up. It has a DB9 male on it, but fortunately came with an adapter that goes from DB9 female to DB25 male. With this, I can plug directly into the DB25 female on the modem and connect it to an available USB port on my Mac. This is the setup I've described so far to get the Texas Instruments Model 707 to speak to my Mac, and vice versa. If this TI Model 707 had an RS-232C port, like another DB25 or DB9 connector as most terminals do, then I wouldn't have needed to bring the Hayes Smartmodem into the picture, and this process would have been much simpler and more straightforward. Next, I'm going to check my USB tree to confirm that the serial adapter I've plugged in is recognized as such by the system. If the serial adapter is working and it's Mac compatible, it will show up. But what about making the Mac listen and speak to the serial port? For that we need some software, and fortunately there's CoolTerm. I'm using version 2.4.0, which is the latest version as of the time of this video. Let's test the Mac and see if the Mac is communicating with the modem. Go to Options. I'll select the name of the new device in my USB device tree that I found in my system report. Choose the serial port. I must use 300, 8N, no parity, 1, OK. Then connection, connect. What I should see on the modem is the receive and transmit lights blinking as I type characters to it. We're almost there. To get a communication link between the Model 707 terminal and the terminal running on the Mac, we need one device to initiate the communication and one to respond. The end that initiates communication is said to originate, and the end that responds is said to answer. It doesn't matter which end originates and which end answers, but one way is easier than the other. Here's an overview of getting the two terminals to talk to one another now that I have the Mac set up. It's a nuisance to move my Mac, so I'm going to leave it where it is. But the Model 707, I'm going to have it as far away as possible, perhaps another room, however far my telephone cable reaches. Let's go to Connection, Options, my serial port at 300 baud, 8N1 is fine. Okay. Connect. Let's go online. Command D. There we go. Has to be online. Okay, 1, 2, 3, 4, 5. It's a perfectly good number. Let's try talk to the modem. AT. It's okay. ATA. I pressed O, I got the message connect, and yes, I got it, carrier, and it's at low speed. And if I hit return, I can hear the paper advancing in the other room. Okay. Hello, Mr. Brown. What did I get? Paper advance. That's hello, Mr. Brown? Yes, that's hello, Mr. Brown. I need to change the local echo so I can see what I'm doing. Turn on connection, options. I want to get local echo so I can see what I'm doing. So let's try this again. Hello, Mr. Brown. Hello, Mr. Brown. Excellent. Paper advance. There it is. Hello, Mr. Brown. Let me see if I can send a file to this. Because they're connected. That's cool. Okay, connection, send file. as raw, yes. Select file, send. Something's gone wrong. It stopped printing. But the smart modem has told us what the problem is. It says no carrier. For some reason, the link between the two computers has been broken. The carrier has been lost, so they're not talking to each other anymore. The Mac is still trying to send the file, though it's only going as far as the smart modem, no further. If we'd set up something called handshaking, then CoolTerm would have been aware that the remote terminal, the Model 707, was no longer ready for some reason, and it would have stopped sending the file. I don't know why the connection dropped. Let's cancel the file transfer and reconnect. I'll clear the buffer here and go over to the Model 707 to get it to dial and originate again. Command D. Okay. 1, 2, 3, 4, 5. It's definitely online. No uppercase. ATA. The characters are echoing, that's right. No response from the smart modem, and I'm not hearing an answer tone. Why? I don't know what's gone wrong with my modem. All the lights are out. This was unplanned.
I'm afraid this video has taken an unexpected turn. I wasn't expecting my modem to die. The fault, actually, I've discovered with an ohmmeter, is the fuse. The fuse is open. Fuses can open for no reason at all, but they can also open if there's a fault. This video is not about repairing Hayes Smartmodem. I can't do any more videoing, but I can put together what I've got.
I was still able to show how to connect two dissimilar terminals together and get them to communicate with one another. I'd hoped to try a few interesting tricks once the terminals were connected together, but I guess that will have to be in a future video, possibly with a different terminal that doesn't use a smart modem. I have a few. I hope you enjoyed this video from Mr. Brown's Basement. Please like and subscribe to see more interesting and unusual videos, and as always, thank you for watching.